Good afternoon to one and all. Today we are going to discuss about introduction about compiler design. In our programming accepts, let us see how we are going to use this compiler design. Okay. In this today we are going to discuss about some introduction about compiler design and what is the history about that compiler and why we are going to study this compiler, and while doing the compilation which type of translators we are using and the structure of compiler and compiler construction tools. Today we are going to learn about these contents. Okay. Initially, what is compiler? A compiler is a computer program that transforms source code written in a high level language into low level language. Language may be assembly language or machine language. The language should be in the form of zeros or ones. After that, introduction. If you take some coding, some for loop, sum is equal to 0, for x is equal to 3, x less than 5, x plus count less than. For this program after doing the compilation program, the source code will be converted into a target program. See here, for example, we can see the program will be converted in this way. The normal C program is converted into in the form of zeros and ones. Next. Basically, compiler does two things. First one is analysis and second one is synthesis. Analysis means nothing but while compiling our source code, it will detect is there any errors in our source program. In that way, synthesis means which is translating the source code into a object code depending upon the type of machine. Okay. After that, let us see. While we are doing the compilation, the program errors are difficult to track if the compiler is wrongly designed. Hence, the compiler construction is a very tedious and long process. Okay. After that, while we are going to compile a if any program means at that time some different types of compilers are there. In that one pass compiler. One pass compiler means it compiles the that passes through the source code of each compilation unit only once. They are faster than multipass compiler. Their efficiency is limited because they don't produce intermediate codes which can be refined easily. It also known as narrow compiler. After that, multipass compiler. Let us see what is meant by multipass compiler. It will process the source code or abstract syntax tree of a program several times. It may create one or more intermediate codes. That's why it will call as multipass e-compiler. Each pass takes output of previous phase as input, hence requires less memory, also known as wide compiler. What is the history about this compiler means? Software for early computers were written in assembly language. The need of reusability of code gave birth to programming languages. This need grew huge to overcome the cost restriction of compiler. After that, the concept of machine independent programming gave birth to the need of compilers at the time of 1950s. The first compiler was written by Grace Hopper in 1952 for A0 programming language. The first complete compiler was developed by Fortran team led by John Backus at the rate of IBM. In 1957, COBOL was first language to be compiled on multiple platforms in 1960. Earlier, compilers were written in assembly languages. The first compiler in HLL was created for LISP by Tim Hart and Mike Levin at the rate of MIT at USA in 1962, which was a self-hosting compiler. Most of the compilers are made in C or Pascal languages. However, the trend is changing to self-hosting compilers, which can compile the source code of the same language in which they are created. It is essential. Let us see why we are going to learn about compiler. It is essential to understand the heart of program by computer engineering students. There may be need of designing a compiler for any software language in the profession. Increases understanding of language semantics. It helps to handle language performance issues, and it also give opportunity for non-trivial programming project. And it is also translators. Why we are using translator means, by using these translators, it is important to understand the compiler. The compiler is a kind of translator, which translates high level language to low level language. Interpreter, this software converts the high level language into low level language line by line. It takes less memory than compiler. It takes more time than compiler. It is more efficient in mirror detection than compiler. It takes more time to build. After that, we are going to learn about assembler. This software converts the assembly language into machine level language. Nothing but it will convert the given assembly language program into in the terms of zeros and ones. It offers reusability of assembly code or different platforms. Cross compiler. If the compiled program can run on a computer whose CPU or any operating system is different from the one on which the compiler runs on, the compiler is known as a cross compiler. Next, language translator or source to source translator or language converter. It means it will convert the program into one high level language to the another high level language. For example, if you take a Java code, it can be converted into ASP. Language rewriter. It is a program that changes form of expression of the same language. It does not changes the language of source code. Decompiler. It is a piece of software that converts the low level language to high level language. It is not as famous but may prove a useful to sometimes. Compiler. It is a tool that creates a compiler, interpreter, or parser from the information provided on formal description of any language. The earliest and most common type is parser generator. Linker is also one type of translator. It is a program that combines object modules to form executable program. In this, each module of software is compiled separately to produce object programs. A linker will combine all object modules and give it to loader for loading it in memory. Loader. Let us see what is meant by loader. It is a program which accepts input as a linked modules and loads them into main memory for execution. It copies modules from secondary memory to main memory, and it may also replace some virtual addresses with physical addresses. For example, linker, loader may overlap. Let us see what is the structure of compiler. Compilers bridge the gap between high level language and machine hardware. Compiler requires finding errors in a syntax of program, generating correct and efficient object code, and runtime organization. And last one is formatting output account to linker or assembler. Let us see the main structure of the compiler. In this, initially we will compile any program. Means the number of inside the compiler, what the process will be going to done means error handler, scanner, parser, semantic analyzer, IR code generator, optimizer, code generator. After all accepting all these, after moving after testing all these stages only, it will give the result to the symbol table manager. After that, compilation, front end. It also known as analysis part. Under this analysis part, what are the stages will come is lexical analysis, syntax analysis, semantic analysis, intermediate, code generation. Front end is mission independent. Compilation, front end. It determines operations impiled by the source program, which are recorded in a tree structure called the syntax tree. Breaks up the source code into basic pieces. while storing information in the symbol table. And it is also a backend. It also knows as synthesis part. Code optimization, code generation will come under this backend machine independent. Compilation, compilation backend. Construct the target code from the syntax tree and from the information in the table symbol table. Here code optimization offers efficiently of code generation with least use of resources. Okay. Thank you.